All right, now I know some of you guys, once you saw these words, completing the square, you've already checked out. Or maybe you're going, wait a minute, maybe now I'm finally going to get it. And that's what my goal is, to help us understand a little bit about this concept that, or a tool or a technique that's going to help us to solve quadratics. So what is completing the square? I don't know, but I know I like starting off with pictures. So let me draw a picture for you. Imagine that we are starting off with some start of a quadratic. I'm going to call this one x squared plus 8x. Well, what does that mean? Well, let's draw a picture first. X squared is basically a square. And what's the dimension of the sides? Well, it's an x. It's an x by x, and that's an x squared. Then 8x. What's 8x going to be? Is that a square? Well, no, in this case, it's a rectangle. So let me draw a rectangle. And we know that one dimension is x, and the other dimension is an 8. And you can see that, yeah, that makes sense, Willie. This is an x squared. This shape right here, its volume or its area is an 8x. All right, so let's go on now and imagine what I'm going to do next with this. So let's take this 8x and let's divide it in half. So each one now becomes, and let me try to get a different color here for us. Each one, so this one now is an area of 4x, and this is an area of 4x. Then I'm going to take both of those pieces, and I'm going to rearrange them. Let's bring the x squared term right there. That was our x squared. Let's take one of these 4x's, and I'll draw it in pink just so we have an idea. So this bottom one, I'm just going to shift it down right underneath of here. And this one has a dimension of 4x. I'm going to take this top one that I cut in half, and I'm going to rotate it right here. And we know its dimensions are 4 by x. So here's a 4, and that's the x. And this is a 4x. What's missing? I have one little piece of a little chunk that's missing here now, which means I want to complete the square. I want to figure out what this dimension is right here. And I know what that dimension is. I have a length of 4, and this length over here is a 4, so that makes us 16. So given that, starting with some x squared plus 8x, I decide to take the second term, the 8x, cut it in half. Shift one here, put one up there, rearrange them, and then to complete the square, I want to add or figure out what is this missing corner piece. And in this particular example, this missing corner piece is a 16. So from 8x or from x squared plus 8x to complete the square, I need to add 16 to it. And now what I have is I have a perfect square. And you can see the dimensions. This dimension was an x, I have a 4. This was an x and a 4. How do you find the area of a square? Length times width. X plus 4 times x plus 4, or just x plus 4 squared. And that is what I have right here. This is, if I were to factor that down, this is x plus 4 times x plus 4, which is now our squared term, x plus 4 squared. So I hope you understand a little bit of where the picture comes from, why we call it completing the square. Because we're looking for this corner piece that has the exact dimensions that we need to take this emerging quadratic and form it into a quadratic that is a perfect square. And if we can do that, that's going to help us solve some very difficult problems. So we already saw earlier how we can get x squared plus 8x, and what's this magic term to turn into a perfect square through completing the square. Let's look at a couple more examples and kind of learn the algorithm of what we did here. Because in this first one, we took the middle term, divided it by 2, and then squared it to get that corner piece. So likewise, we're going to do it here. Numbers may not be as clean, but it's still the same process. So let's look at the middle term, which is a 7. We're more interested in the coefficient for this case. the coefficient's a 7. Well, it's a negative 7. So we're going to take negative 7, divide it by 2, and then square it, which becomes a 49/4. So that's the dimensions of that corner chunk, that corner piece. So we're going to add a 49/4 to this term, and now we have a perfect square. Where this one before was an x plus 4 squared, this one is now an x minus a 7/2 squared. Another example, x squared plus 3/5 x. Doesn't matter that this term is a fraction because we know how to work with fractions with our practice. So again, we're going to take this middle coefficient, because remember, this represents a dimension of a rectangle. And we want to cut that rectangle in half, rearrange them into a square so we can start creating a perfect square. I guess all squares are perfect. So 3/5, divide that by 2. How do we do that? 3/5 divided by 2. Flip inverse, so it's 3/5 times 1/2. That equals 3/10. And then from there, we're going to take that result and square it. So we're going to have 9/100. So to complete the square, the dimensions of that corner cube was dimensions, fractional dimensions of 9/100. Whoops, sorry, of 9/100. And actually, yep, 9/100. And then from there, the perfect square then would be x plus 3/10 squared is the dimensions of that perfect square. And again, or another way, how I get this last term, the 16 on the beginning one turns into 4. It's basically the square root of this number produces that number. Square root of 49/4 is 7/2. Except we have a negative on this particular one. 9/100, the square root of that is 3/10. And so sometimes I keep that in the back of my mind to help me understand, all right, I know what the magic number is, but what's the perfect square factors where that comes from?